Hey guys, welcome back to my YouTube channel, Steve Learning Note. And in this learning note, I'll share you about observability with OpenTelemetry. I hope you enjoy it. We are going to learn about observability, trace, log, metrics, baggage, collector, and finally sampling. What is observability? Observability is the ability to understand the internal state of a system based solely on the external data it produces. And with this data, with this rich context, hopefully we can answer critical questions like why did it happen, how the issue happened, when did it happen, and where did it happen. And what is telemetry? Telemetry is an automated process that collects and transmits data from remote sources to a central locations for analysis and monitoring. So with telemetry data, we can use for doing observability. So for illustrations, we can have sources. It can be our applications, our infrastructures, or cloud platforms, and then there will be telemetry pipeline, and then we can send these telemetry data to the pipeline. So inside the pipeline, it will collect and then do some processing and then finally export the telemetry data to destinations, or usually we call it backends. And this backend can be a SIEM or security information and event management. It can be observability platform. It can be a data lake, database, object storage, or maybe we can just discard it if you want. And speaking of observability, usually there will be three pillars of it. And the first one is logs, which is a recording of an event. Second one is traces, which is the path of a request through your applications. And the third one is metrics, a measurement captured at runtime. So for example, if we have a burger shop and then we have a log of order 1, say that triple patty burger burned out at 10 a.m. due to a cook failure. So these informations can be provided by logs. And how about traces? So for example, order 1 took 30 minutes to be completed, 5 minutes for preparations, 20 minutes for cooking, which usually less than that, but because the burger burned out, so we need to redo it, right? There's the delay, and 5 minutes for delivery, so it took 30 minutes. And metrics, with metrics we can get information like how many burgers that we sold per hour, in this case 50 burgers per hour, with average time 8 minutes. And speaking of tracing, I want to connect it with OpenTelemetry. So as we know that tracing is application flow, and distributed tracing is a technique to use to monitor and track the flow of requests as they traverse through a distributed systems like a microservice architecture. So this is an ability for us to see the trace in different systems. And between 2016 and 2018, if you want to instrument trace or distributed tracing, there are two options. We can use Open Tracing by CNCF or Open Census by Google. These were two competing standards that we need to make decisions. So in 2019, they announced OpenTelemetry, which basically a joint force between Open Tracing and Open Census. They merged together and make a new platform called OpenTelemetry. So OpenTelemetry, or in short OTel, nowadays is a de facto standards for doing the telemetry. Well, it's not the only one, but it's de facto standard. And what makes OTel great, I think, is because it has protocol called by OTLP. It is a general purpose telemetry data delivery protocol designed in the scope of the OTel project. And with that, it allows us to send data without knowing the destinations of the backend. So it's vendor agnostic. And the second thing that what make OTel great is the SDKs. With the provided SDKs, it can help us to instrument the applications to send the data to any backends. We don't need to care what will be the backends. We just need to use the provided SDKs, which is it's open source. And as in October 2025, OpenTelemetry support 3 stable signals. They call it that way, not pillars. There are traces, metrics, and logs. And they are in the process of development of 2 additional signals, which is profile and room, or real user monitoring or real user metrics. So just for illustrations, between sources and the pipeline, and from pipeline to the destinations, we can use OTLP as the protocol. We can use another protocol if you want. Let's say some backends maybe not support OTLP yet. We can use that. It gives us flexibility in choosing the protocol, but in general, the best practice nowadays is by using OTLP protocol. Okay, next, let's discuss about trace, the path of request through your applications. We usually use trace to debug our applications with causality. Causality means, for example, A happened because B happened before, right? A happened because B happened before. A happened caused by B. So that's what causality means. And then it enables us to see a complex system overview, because with trace, it can generate a trace waterfall, like in the top pictures. And also it can generate a service graph, like in the second picture, which showing us a service interconnections. And trace has high cardinality and high dimensionality. So we can put a lot of context in the trace. Span is basically structured blob of data. It has unique ID, or we call it span ID. It has correlations ID, which is the trace ID. It has start and end time, and it has the causality ID, or in this case, it will be the parent span ID. And it has attributes that we can set based on our requirement. Basically, trace is a group of spans with the same trace ID. So if you can see here, a trace consists of multiple spans. And these spans will have one trace ID, which is the correlations ID. And each span will have unique span ID. And a span can has a parent span ID, which showing us the causality, right? So E happened after D, D happened after C, for example. And we use context to distribute the span. I'll show you about that a little bit more later. And in Go, we can instrument the trace using these library that are provided by the SDKs. So first, we can generate resource. So resource can add details about our application's environment to our telemetries. For example, we want to give information about service name and service versions of our applications. And then we can have functions to create a trace. Okay, the first step is to initialize the exporter where we want to send the trace data. In this example, I use HTTP exporter, which I will use OTLP, send the trace data using HTTP with binary protobuf payloads. Note, we can send telemetry without OTLP by using vendor-specific protocol if we want to. After we have the exporter, next we need to create the provider, which provide access to generate trace itself. It also manages sampling, span limit, and ID generator for trace and span. And with batcher here means it will send span in batches to the exporter. And then we set the R, which is the resource that we created here in the provider. And then we set the trace provider to the global trace provider so we can reuse that later in another code. And then we set the propagations and the gauge. So I will talk about these two later. So let's see about how to use the trace in Go using the middlewares. So first, we need to create the tracer itself from the provider that we just generate. We give the instrumentation name. In this case, I use this import path who instrument the tracer, and then I give the version and then the schema, right? So it returns a unique tracer for the scope defined in instrumentation name. So this tracer is a tracer for instrumentation name scope. And how to use it? It's simply just calling that tracer and then access the method of start, and then you can give the name of the span, and then after your function's done, you end the span, and then you can also set status. Let's say here I receive an error and I want to set the span status to error 2, indicates that this flow has some error. So we can also instrument our HTTP handler with middleware. Right? In this case, I'm using SDKs, OTel HTTP new handlers. With this SDK, it will inject tracing and metrics to our HTTP handler automatically. So we don't need to instrument that manually. It's already handled by that. And I'll show you what the data that is provided by using this middleware. Now, before that, I will show you about context propagations. In OpenTelemetry, context refers to the mechanisms used to carry metadata across process boundaries and different layers of an applications. It is an essential part of distributed tracing and logging, and it allows for correlations of telemetry data across various services in a distributed system. And the tracing HTTP request headers comply with W3C standards. The W3C standard for tracing HTTP request header is referred to as trace context. So for example, you have service 1, which call API in service 2. And then we want to make sure that our trace, right, also visible in service 2, right? So when we saw the trace waterfall, you want to see that our service 1 call this span 1 and span 2, and after that it calls service 2, and service 2 has its own spans, and we want them to be connected so we can see the overall spans journeys. And to do that, we need to inject the context propagations when sending the request, and that context propagations will be sent via HTTP headers. And then when the service 2 receives that request, it will extract that propagations and use that to propagate the spans that it will use in its own trace. And inside the header of the context propagation, there will be key of transparent. And the value will be like this. So the first 2 digit is the versions, which right now is always B0. And the next part, the orange one here, is the trace ID of the previous service. And the green part is the parent ID. And the last part is the trace flags. 1 means this trace should be sampled. 0 means it should be not sampled. I'll talk about sampling later. So how to instrument the context propagations? So if we use HTTP, yeah, for example, here we can set the propagations with new composite text map propagator. And then we set what propagations that we want to use. In this case, we want to use the trace context and the baggage. So we want to send the trace context and the baggage to the next service. And then we set this propagation as the global propagator. So that when we create an HTTP client to send our request, we can use the SDK of OTel HTTP. There will be a function called new transport. And this function will inject the span context and also baggage into the outbound request header and enriches with metrics. So then when we see the waterfall of spans in Jagger, for example, in this case, we can see that it begins by a request to this slash order in order service, and it has the 22 spans, right? And has 8 depths across 2 services. And this is the total durations. And then this is the span child. Create order and then create order. There is a publisher. And then eventually the order service made an HTTP post to notification service. And then we can also see the spans that was generated inside the notification service under the same trace ID. And if we click the span, we can see the span detail, and we can see a lot of information here that was automatically instrumented for us by just using the instrumentation tools that I have shared before. So we can see the body size, the method, status code, the root, the IP address, and etc. etc. And also if we set a custom attributes, it will be visible here. And if we have if we have infrastructure like database, for example, we can also instrument that connections with OpenTelemetry so that we can see what happens inside the connections. So in this case, I use Postgres. So I use this library from Xaring that will automatically inject instrumentations when we use the Postgres connections. So these 2 spans are automatically generated and instrumented for us. So we can see that in some time, the flow call pool.acquire to get the connection pool, and then it runs this query, right? And then it show the rows affected number and another valuable informations from the trace. Next, I'll talk about span links. Span links correlate one or more spans together that are causally related but don't have a typical parent-child relationship. These links may correlate span within the same trace or across different traces. So for example, I have product service, a user call the sell product API. So, and then it saves some data to database. And then we have trace for this flow. Let's say 100 millisecond. And then after that, this service send event, product created event. And this event will be consumed by 3 different services: fraud, inventory, and search services. And let's say this causing an extended trace to 1 minute. So if we use context propagations for this case, where let's say all of these spans will be in the same trace ID, our trace of product service for sell product will be very long, and it will be very complicated, like too many information under one trace. Okay. So ideally for this relationship case, we want only to focus on this area and then this area. So these two areas should be separated, right? But there must be a way for us to link back to the original span if you want. So for example, prod service receive the event of product created event. Yeah, this event with span links. All right, even though the parent trace is different, but with span links, when we visiting the fraud service trace, we can check who generate this trace before, right? We can click that link, and that link will give us to this trace ID. So we can see the causality, not with the parent-child relationship, but with span links. So without the span link, the trace can be very long and too complicated. Span link can help individual pieces of the system be completely independent. Span kind. Span kinds clarifies the relationship between spans that are correlated via parent-child relationships or span links. So there are 1, 2, 3, 4, 5 type of span kind. The default is internal. And then we have client, and then it has client direction outgoing, right? And with communication style request or response. And then the span that we receive request from the client should have server kind. But if the communication style is deferred executions like PubSub, right? The publisher should have span kind of producer, and the consumer should have span kind of consumer. So this is the attributes of span kind. And we also have semantic conventions. It's not just for trace, basically, it's for another type of signals. The semantic conventions define a common set of semantic attributes which provide meaning to data when collecting, producing, and consuming it. The semantic conventions specify, among other things, span names and kind, metric instruments and units, as well as attribute names, types, meaning, and valid values. So for example, if you want to send information about HTTP request method, we should use these semantic conventions, http.request.method as the key of the data, right? And then server.port, for example, and etc. So you can check the documentation here. So now, how to propagate for producer, right? So for producer, if you want to propagate context propagations, the mechanics different with HTTP, and maybe also different depending on what technology you use. In this example, I use NATS, PubSub messaging. Okay, so this is the functions that will send message via NATS. And this span, I set the custom attributes. With semantic conventions, I set that the messaging system key, yeah, the technology that I use to publish the message will be NATS. And then the destination name Yeah, in this case, in the context of nets, it will be the subject, right, or a topic, and the operation name will be send. And then, oh, sorry. And then here, I set the span kind, right? If you remember, to producer, because the communication style is deferred communications. And I set the custom attributes as what I said before. And then the third one, I set propagation carrier with HTTP header semantics, right? So I create the nets header and I use the header carrier and I inject the trace propagations to this carrier, right? And then the header of nets will be injected by the context propagations, and I will send that along with the message that I will publish. And in another side, for the consumer, I need to extract the context from the header, right? Basically, this is the code. Like, I need to get the normalized header from the header carrier and extract the context propagations. And then I will create the span link with that context propagations. So here I create the span link with the trace context that I get from extracting from the context. And I can also set custom attributes here if I want. All right. So here I extract the context and I create the span link. And I will use this link when I create the new span in the consumer. So this I create a new span. Sorry, I create a new trace, right? With the links, and I set the kind. The most important one here, I set these options with new root. So it indicates that I want to set a new trace with no parent span. Otherwise, if you don't set this, it will use a parent-child relationships rather than you will use parent-child relationships. So your trace will be very long. So you have to disconnect them here. But again, it depends on your choice. And also I can set custom attributes with semantic conventions. So for example, here's the consumer part. I have a cook service that will receive an event. And then when I click into the first span, there will be references. This is in Jagger, right? And when I click this reference link, it will open another span, which is the publisher, right? This is the publisher who sent this event that received by this operation in this trace. So these two are connected not using the parent-child relationship, but by using span links. What is span event? A span event can be thought of a structured log message or annotations on a span, typically used to denote a meaningful singular point in time during the span durations. So for example, in this flow, I want to use span event to annotate that at this time of the flow, my retry logic when querying to database is triggered. for example. So this is another example, span event example, right? Still in cook service, I have two events here. One in here in the beginning of the trace and at the end of the trace, right? These two. And there is a section of logs. And each of these event, we can see what attributes that we log, right? So we can add custom attributes into the event. We can see that, oh, this is an event of cooking is starting, right? And it begins at 500 is nanoseconds. And the last event is when the cooking is completed. We can see that the cooking is completed after 5 seconds from the first event. So this is a nice features, right? If you need to log something that is time sensitive. So it's different with attributes. So next, oh, wait, why it jumps to collector. So next, let's check about log, a recording of an event. Log can give us information about something happened in specific time. It is designed for humans. Why? Because log can be structured using JSON formats. Easier to read, to understand. And most importantly, it has a log message, which human readable. And log mostly useful for startup or crashes, because at the time, usually trace is not available yet. And it's useful for canonical log. So if you are not familiar with canonical logs are single log lines that you add at the end of every request that summarize the key telemetry data about the request. So for example, on the right, you can see a log message that is added every request ended to summarize that request. It has the message, it has the request ID, durations, information about the protocols, the response, and maybe some database operations. To instrument canonical logs, to instrument log in Go language, right? We can use OTel HTTP exporter if you want. In this case, I use HTTP exporter. Another option is by using gRPC exporter. Okay. And then I use, here. What I want to highlight is that I use gzip compressions. And then the second point is I want to set a log processor. There are two processes that I use here. First is a batch processor, which will send the log in batches. And second, there is a min-save processors, which will set minimum log severity level to be sent to the backends, right? So for example, for debug log, I don't want to send it in productions, maybe, right? The minimum level of severity will be information, let's say, or maybe warning or error. And then I set the log provider, similar with what we have done in Trace, and then set the log provider to the global log provider. And then after that, we need to create the logger. In this case, I use slog, which is the built-in log library for a structured log in Golang. Right. So in this case, for environment local, which is my local environment, I want to output the log to standard output and also OpenTelemetry. So it is easier for me during the development, right? And here I use thin library to color the log, or else in another environment, I'm just going to send the log into OTel using OTel. So to instrument canonical log for Gochi, because in this example I use Gochi routers. Luckily, there is an existing log library called HTTP log for Gochi, which can instrument the canonical log for our HTTP router. And the most important options here probably this schema, where you have to set it with OpenTelemetry schema. How about the nets that I used before? For nets, I couldn't find any pre-built library, so I need to build by myself. So I create a log middleware, which basically will set these attributes: the system key, destination name key, operation type key, body size, the process durations, right? And I will also log the message ID, and then we'll put it into the canonical log. So let's see. So this is the log that is exported to the standard output with the tint library, right? It has some nice color. It's not in JSON format. For me, it's much more easier to see rather than using JSON in the standard output. But we also export it to OpenTelemetry. In this case, I use Grafana using Loki. So you can see this log of some error operations, and these fields are automatically instrumented for us with the instrumentations that I have shown to you before. So we don't need to do this manually, right? So this is the canonical log that I talked before. And you can see here, log is already have span and trace ID. Nice. It means we can see the related trace ID in our trace view by clicking this link, for example, in this UI. Okay, let's go to metrics. A measurement captured at runtime. Metrics as time series aggregations. A metric is essentially a numerical measurement that changes over time. Each metric is stored as a time series. Time series means it has data points like pair of timestamp and value. It can have labels or tags, yeah, which is a key value pairs that give dimensions to the data. So for example, if we have metric name like HTTP request duration seconds, and then we set the labels like method, status code, endpoint, we will have data points like this. This is the data point. So this is the date, the timestamp, and then this is the value, which is the request durations. So this is the data points. And then the combinations of matrix name and labels, yeah, uniquely identifies one time series. And in practice, we often aggregate these values over time windows, like using average or sum or count. And metrics are cheap to store and cheap to query. Metrics are designed to be lightweight because they store numbers, not full event data like logs, for example. And they are aggregated. You don't need to keep every row event. You just need to keep the counts, the sums. They are often stored in compressed time series database, which are optimized for sequential numerical data. So instead of storing every HTTP request event like logs do, a metric might just store in the last 10 seconds, right? There were 500 requests and 5 errors, let's say. And that's thousands of times cheaper in terms of both storage and query performance. But metrics lacks deep context. Metrics are great for what, but not why. They tell you that something is wrong, like error rate increased to 10%, but they don't tell you which user or request caused it, what stack trace or message was involved, what request ID or trace it belonged to. So you need another signals to answer that questions. And last, metrics have low cardinality or dimensionality. Cardinality in this context means number of unique combinations of label values. Metric system perform well when the number of unique label combination is small. Example, if we have metric name HTTP request total with labels, method, status code, and endpoint. And let's say we have 3 possible values of method, and then we have 5 possible values of status code and 10 possible value for endpoints. In this case, the total time series that we will have is 3 times 5 times 10. So it will be 150, which is, it's still fine. But imagine that if we add another label like user ID with thousands of unique values, you might create millions of time series. So it will blow up your storage and query performance as well. And in OpenTelemetry, it supports these metric types. You can pause and see. The first column is the name, counter, asynchronous counter, or observable counter, up down counter for asynchronous, histogram, gauge for synchronous, and gauge for asynchronous. Type of communication, synchronous or asynchronous. Is it additive or not? Is it monotonic or not? And then what it represents. So for example, counter, you can use it for cumulative counts of events, right? Asynchronous counter is cumulative total observed periodically. And then you can see also when to use, or example. Let's say you can use counter for request count. You can use asynchronous counter for total CPU time observed via callback, and so on and so forth. So you can pause and see the metric types comparisons that is supported by OpenTelemetry. So if you are not familiar with additive, what is additive and what is non-additive value? The definitions. An additive value means you can meaningfully sum or add up multiple observations over time across dimensions. It represents something that accumulates, like counts, totals, or durations, where it makes sense to aggregate the values together. Example, number of requests served. Why additive? Because we can sum requests over time or per instance. Byte send, CPU time consumed, order create, right? So for example, if instance A proceed 10 requests and instance B proceed 20 requests, total request is 30. And that makes sense. What is non-additive value? It means you cannot meaningfully add values together. They represent states, level, or measurements that don't combine by summing. It's a snapshot of quantity at point in time, not something that accumulates. Example of non-additive metrics, current temperature. Why it's not non-additive? Because adding, let's say, 25 degrees plus 30 degree somewhere else, right? You add up, it doesn't mean anything, right? Memory usage, it's not additive. Why? Because they are separate systems. Combine for what? Queue length, this usage, right? It's not sense to add both value. Okay, how to instrument metrics in Golang. So first, you need to, again, set the exporter. In this case, I use OpenTelemetry HTTP exporter SDKs. And then I set the provider, which will export the metrics periodically. In this case, I set to 3 seconds, right? And then I will run another library that is provided for us, yeah, instrumentations, host metrics. This is an optional, right? It enables host metrics instrumentations like CPU, memory, and IO usage. Runtime. This will export and report Golang runtime metrics like coroutine, GC, etc. Heap. Okay. So this is the example, right? So maybe it's too small, but it's okay, I think. So export the metrics to Grafana. So with all of that instrumentation that I showed you before, including the instrumentation in the XTP router, when I discuss about what's that, trace, right? So you can get all of these informations by default. Of course, you still need to build the dashboard. Okay. So we can get the latency by endpoint. You can get the error rate by endpoint. We can have request rate by endpoint, request rate by status code. We can have memory usage. We can have go routines. We can have database operations durations, database connections, pooling status, and etc. etc. Okay, this is the example. How about we want to create custom metrics? Yes, it's possible. So you need to set the custom metric first. In this example, I need integer 64 counter. Yeah, counter is one of the matrix type. And then I need float histogram, right? This is the name, descriptions, and the unit. To use it, you just need to call it the method add for counter by 1 for this sample. And then you can also set the label, right? The attributes, in this case status, to success. And then you can export it to the Grafana in this case. You can have your own custom metrics, let's say a business metrics, right? In this case, I have the order creation rate, total orders, order amount distribution, popular items, menu view, rate, total order, cook time, cooking durations, email delivery rate, etc. etc. Okay, so next, let's talk about package. Contextual information that is passed between signals. Baggage is an additional context between services, right? So for example, this is service A, service B, right? And then using baggage, you want to pass client ID, right? So you can set the baggage here in this parent span, and that informations can be carried on through its child span and eventually to another service that that will receive the same context propagations. So service B can extract the baggage and use that information too. So it's different from attributes, right? Attributes is set per span child, right? For baggage, you need to extract it manually, and then you can put it in the attributes if you want. And it's dangerous. Yes, it's dangerous because if you set a sensitive informations and then you export it to third-party vendors, right? That third-party vendors technically can also extract the same baggage informations. And the baggage here is not new technology, it's a W3C specification basically. So how to add baggage? To add baggage, we just need to add this. Sorry. All right, so how to add baggage? To add baggage, right, we can use this library baggage, okay? And then I create the member, give it a name, for example, order.id, and then use that member as a set member here. Okay, so I create a member first and then set that member. And then I pass this baggage in the context, right? So this context will be carried on to the child spans. And then those child spans or another service also can extract this baggage from the context. How to extract the baggage? You can do it manually, but you can also use baggage copy processors. In this case, I use baggage copy processors inside the span processors because this is trace, but you can also use it in the log or in the matrix, right? And then I set an options to allow all members. So I want to add all baggage key, but you can also be more specific, right? Maybe you want to extract specific key or by regex, right? You can do all of the stuffs. Okay, that is baggage. So now let's talk about OpenTelemetry Collector. It's a vendor agnostic implementations of how to receive, process, and export telemetry data. OpenTelemetry Collector. We can use that to centralize config or exporter. Right? So imagine that if you don't use collector, right? And then you have a lot of applications, and each application will have to store the backend's key, right? And then you need to rotate that key at some point, maybe. That will be troublesome. So if you have OTel Collector, you can centralize the API keys management. So you just need to rotate the key inside the OpenTelemetry Collector. And then we can also use OpenTelemetry Collector to send the telemetry, where to send telemetry, right? We can manage the routing there. So let's see the picture on the right. This is the OpenTelemetry Collector. So your applications will send the data to OpenTelemetry Collector. And OpenTelemetry Collector will receive that and do some processing, export that to backends, right? Using one of these protocols. And also, OpenTelemetry Collector can be used to secure egress. So for example, your applications is an edge computing and it does not have network connectivity to outside, and then it want to send the telemetry to the collector, and collector can allow specific address, to whitelist specific address under the firewall. So this edge computing can still send telemetry data to specific endpoints outside the firewall. Okay, so this is the definitions. Collector can act as a secure policy control bridge between your isolated edge nodes and your central telemetry backend. And collector can be used also for redactions or filtering. I'll show you some examples later. There are three components of collector. First is receivers. Receivers are the components responsible for collecting telemetry data from various sources, serving as the entry point into collector. Receivers, right? It can be using OTP, or maybe Prometheus protocol, or Journality, or another protocols. And then there will be processors. This is the component that modify or enhance telemetry data as it flows through the pipelines. It can do batching, transforming, sampling, and other stuffs. And then, finally, exporters serves as the final stage in the collector's pipeline and are responsible for sending processed telemetry data to various backend systems. So this is the configurations of OpenTelemetry sample in YAML file. The configurations block is divided into 4. One is receivers, processors, exporters, and then there is extensions, right? Where we can extend the functionality with provided extensions. And then service. Service here means that what functionality we want to enable in the pipelines, right? We can define the receivers, processors, exporters, and extensions, but to enable that, we have to put them inside the service block. And we can also validate these configurations using this command, OTel validate, and then the path. We can also use these tools, OTel bin.io. You can copy this configuration to this website, and it will validate and give you the visual of your telemetry pipelines, right? This is for trace, for metrics, for logs. For trace, in this example, I use OTLP, and then the purple one in the middle is the processors, where I use memory limiter, batch, tel sampling, attributes, transforms, and then finally I export it to via HTTP to Jagger. Also, I export it to LGTM stack and to debug endpoint, right? And also you can do this with another tools called, I think, ZPage or something. I forget exactly the name. Oh yeah, Z pages. Yeah, if you enable these extensions, Z pages, you can also view these informations, right, directly from your OTel collectors. So you don't need to share your informations with these websites. All right, so redacting sensitive data example. So I want to redact. Yeah, I want to, and also I want to hash, right? Hash emails, for example. Email is one of the PI data, right? So I have two examples. This key customer.email, yeah. I want to hash the value, but for trace with this key email, I want to redact. So inside the configurations of collector, I can set two processors. One is attributes and the second one is transform. With attributes, I can define the key, in this case customer.email, and the action, which is has. And with transform processors, right, I can define the regex pattern of email, right? And then if the span has these attributes in its value, right, I will replace it with this text redacted. And then after I define the processors, I need to enable it inside the service pipelines. In this case, inside the trace. So I add attributes and transform for the trace processors. And then we can see the informations here in the span in the UI. Customer.email is hashed, but for email is redacted, right? Telemetry routing sample. So for example, I want to route the telemetry data into two different backends, right? So here I have exporters to Jagger and to LGTM stack. Okay, and then in the pipelines for trace, right? If you see in the exporters, I set Jagger and LGTM. So for trace, the data will be exported to Jagger and LGTM at the same time. Right, so let's continue to OTel Collector deployment. There are three ways to deploy collectors. One is without collector. So from our applications, we set up the SDK and then we export the data directly to backend. It's simple to use, but strong coupling between the application's code and the backend. So if you need some changes in the configurations on how you want to export your telemetry, you need to change the code in your application and redeploy it, right? The second options is to use agents. So you install the collector as separated daemon set, or in the Kubernetes, you can create a sidecar container, for example. So with this approach, we can have a clear one-one mapping between applications and collector, but it has a scalability issue, right? Because it's still that all the configurations of your collector will be provided in one applications. And it doesn't scale. If this collector dies, you cannot send the telemetry. And the third options is via gateway. So you have a cluster, not cluster, you have multiple collectors. And then behind this, not behind, so before this, you have load balancer, let's say Nginx, that will load balance the traffic. So this is very scalable. You will have a centralized policy management, but it has a higher complexity and cost compared with the other two deployment techniques. So this is your choices. It's available for you. Next, the last thing that I want to share is about sampling. It is a process that restricts the amount of spans that are generated by a system. With sampling, we can reduce the cost of observability without losing visibility. Right? So imagine that you have this a lot of requests, maybe like 1,000 requests per second, and those requests having no issues. Do you really want to send all of the trace or the logs to your backends, right? If you do that, maybe the cost will be very high, right? But maybe what we want is to just sample some okay traces, and maybe we want to sample trace with specific attributes or traces with high latency. And I think the most important is trace with errors because we want to debug that, right? So there are two techniques to do sampling: head sampling and tail sampling. Head sampling is a sampling technique that is decided whether to sample or not before activity creations. So before producing the trace, before producing the span, the sampling decision will be made whether to sample or not. It is easy to configure via SDK in our applications. It removes process overhead because we don't need to, we don't need to compute these trace and spans. We don't need to store them in the memory if we decided not to sample, right? So it removes process overhead. But it's not possible to make sampling decisions based on data in the entire trace. So it doesn't have access to the context of the spans. It doesn't know if whether these HTTP requests will be an okay one or it will be have error, it will be have high latency. It doesn't know. So that's the weakness, but it's the easiest and a very low process overhead to do sampling. And the other technique, which is the opposite, is the tail sampling, where the sampling decision will be made after the creation of spans. So the decisions will be decided by considering all or most of the spans. And to do this, you need to configure it in the collector. You need to have OpenTelemetry collector for this. And then because you need to make a decision at the end, there will be delay sending spans to the backends because it need to have collect the spans within traces, right? And it requires the app to send all the spans or use more memory and resource in this case, right? If the sampling decision is not to sampled, right, discard it, but you already use memory and resource to collect those spans, right? So that is the trade-off, but you will get more context for your spans. So for example, if you want to add tail sampling, so here we can use the tail sampling processor, right? And there are few configurations that we can use. Not all of them I use here. The first one is decision wait, is how long it needs to wait until make the decisions. Second is how much the trace need to be kept inside the memory. And the third one is number of expected new traces per seconds. And then the policies. we can set the policies. For example, I want to always sample errors. So I can create errors policy with type status code where the status code is error. But I also want to sample 10% of OK success by using probabilistic policy with sampling percentage 10. And then I want to make latency based policy with type latency with a threshold of 1 second. So if the sample has a slow trace over 1 second, it will be sampled. Yeah, that's the end of the presentations. I hope you enjoy and learn something new from it. Until the next video, keep learning and stay healthy.